Now, the next interesting step to this question would be, well, we've got one sodium over there, but what about this hydrogen? Shouldn't this, you know, be also trading out for a secondary sodium from the NaOH? That would make sense because it would want to give that hydrogen away to the water and fully neutralize itself. So, if we did the next round of trading, we would actually have two sodiums swap for these two hydrogens here, right? So let's see what that looks like, because that is a more complete and correct equation. So we'll start with our equation again. Like this. And now, whoops, made a mistake there. We should not have the products yet. We're going to swap both of the H2s on the H2SO4, both of those hydrogen ions for sodium. So swapping that out, we're going to have, obviously they're going to come over to OH and make H2O. And on top of that, though, we're going to have two swapping for the two sodiums, because each hydrogen is a +1, each sodium is a +1. So we'll end up with Na2SO4. Notice how basically all of the hydrogens have gone over to the OH to make water. Okay, let's balance this one. This one's a bit more interesting because we have two sodiums here in the product molecule of sodium sulfate. And so now that means we need two here, but we only have one. That means we need to put a 2 there, right? Now moving on, what about the H's? Let's try the H's. We've got 2 times 1 H there and 2 H's there. That's 4 H's total. So knowing that's 4 H's total, if we go here, we need to make 4 H's somehow out of this. That means we need to put a 2 here, because 2 times 2 hydrogens is 4 hydrogen atoms there. Okay, good. Now let's go on to the oxygen. 2 times 2 oxygen is 2 there. And we've got 4 oxygens here. So 2 and 4 makes 6 oxygen. What about over here? 2 times 2 oxygen, that's 2. And 4 oxygen, that's 6. So that looks good. So I think the rest of these we could just put as 1s. Okay? And now this is the balanced reaction after both of the hydrogen ions have left the sulfuric acid. And this is what the complete reaction would look like. So it is more correct than this one above.